Hi, 7th grade. Welcome to your first lesson of Topic 7, Understand Likelihood and Probability. By the end of the lesson, I want you to be able to say, I can describe the likelihood that an event will occur. Let's solve and discuss it. For a game show, Jared has to choose one of 8 boxes to win a prize. One of the boxes has a big prize, 3 of the boxes have a medium prize, 3 boxes have a smaller prize, and 1 box is empty. How confident should Jared be that whatever box he chooses, he will win a prize? Support your response with a mathematical argument. So I will take some participation. What are the chances that Jared will choose a box with a prize? Okay, I hope you said that he should be confident because most boxes contain a prize. There's only one box that doesn't have a prize, so mathematically 7 out of the 8 boxes, or if we did, remember I said fractions just like division, if we do 7 divided by 8, that is the same thing as 0.875, or it's the same thing as 87.5% chance. That's a pretty high percentage that he will get a prize. Now, we don't know what size prize, but we know he will get a prize 87, almost 88% of the time. Suppose the empty box is taken out of the game. How confident should Jared be that he'll win a prize? Oh, he should be 100% confident, because if the empty box is taken out, 7 out of 7 boxes will have a prize in it. So 100% confident. Every box left has a prize. All right, example number 1. Elisa and Sherry spin the pointer to the right and record the color it lands on. The table shows the results after 100 spins. How can Elisa and Sherry explain their results? There are 4 possible results or outcomes. Outcome is every possible result. That is one of your vocab words. When Elisa and Sherry spin the pointer, the results are the pointer lands on red, pointer lands on yellow, green, or blue. Each section is the same size, and there is 1 section of each color. Each of the 4 outcomes is equally likely because the pointer has an equal chance of landing on any of the 4 sections. Since it's divided up equally, this is fair. There's a fair chance of landing on each part. Each time they spin the pointer, the likelihood or the probability of the pointer landing on red, yellow, green, or blue is the same. Each of the equal-sized sections is shaded one of 4 colors. So the probability of the pointer landing on any given color is 1 out of 4, or 1/4. Since 1/4 is 25%, the probability can also be written as 25%. The pointer should land on each color about 1 out of 4 times, or 25 times out of 100 spins, which makes sense because all of these numbers right here are really close to 25. No, it's not going to be perfect because life isn't perfect, but that's what we can expect to happen. How might the probability of the pointer landing on a given color change for the spinner shown at the right? So now if we look, we still have the same 4 colors, but now there's 2 sections out of 8 for every color. But if we were to reduce that, that would be 1 out of 4. So the probability would not change. It's still 25%. Convince me. How would the probability of the pointer landing on a given color change if the spinner had 6 equal-sized sections, which each section a different color? Well, then each color would be 1 out of 6. 1 out of 6 is equal to 16%. 16 0.6 repeating percent, so almost 17%. So the probability would decrease, going from 25 to 17. Example number 2. Use probability and likelihood to describe situations. Carrie will roll a number cube with sides labeled 1 through 6, a dice. What is the probability that she will roll a 2? Well, there's only one side that has a 2, so it's only 1 out of 6 total sides is a 2. So the probability is 1 out of 6, or 1/6. What is the probability that she will roll a number less than 7? Well, all of the numbers on the cube are less than 7. So it is certain that she will roll a number less than 7. The probability is 6 out of 6, or 1. What is the probability that she will roll a number greater than 6? There is not a single number on the cube that's greater than 6. So it is impossible to roll a number greater than 6. The probability is 0 out of 6, or 0. So now the game piece shows 12 sides labeled 1 through 12. What is the probability of rolling an 11? Well, there's only one 11 out of 12. So 1 out of 12, or 1 over 12. What is the probability of rolling a number greater than 5? The numbers greater than 5 are 6, 7, 8, 9, 10, 11, and 12. That is 7 out of 12, or 7 over 12. And what is the probability of rolling a number greater than 12? 0. 0 out of 12, or just 0. All right. Use probability to examine fairness. Marisol designed a spinner for a game. The spinner is fair if there's an equal chance for the pointer to land on each number. Is the spinner a fair spinner? Well, if you look at the spinner, there's 6 sections, and all the sections are equal. But if you look, 2 of the sections are labeled A. So don't you have a better chance of getting A than any of the other ones because there's more opportunity? Probability of the pointer landing on A is 2 out of 6, which is equivalent to 1 out of 3, or 1/3. The probability of the pointer landing on B is 1 out of 6. Each of the probabilities of the pointer landing on C, D, or E is also 1 out of 6. So it is more likely that the pointer would land on A than any other number, so it is not a fair spinner. Try it. Is the spinner shown a fair spinner? If yes, explain why. If not, describe a change that could make the spinner fair. So no, it's not a fair spinner. There is more chance of landing on blue. To make it fair, you could change the gray section to red. Then there would be an equal chance of getting both red and blue. Or you could change all the red sections to gray. Then there would be an equal chance of getting the same amount of gray and blue. You could change, I think that's all you could do. Okay, key concept. Oh, I forgot example number 3. What was that? That was example 3. Oh, Miss Chester. Never mind, guys. Okay, let's say it. I can describe the likelihood that an event will occur. Have a great day.